Hi, I'm Arjun, and I'm presenting a project where we try to understand and predict visual humor in abstract scenes. In this work, we come to the rescue of millions of teenagers all over the world who every single day agonize over which picture do I upload to Facebook to get the most number of likes. So, which picture would you upload to Facebook to get the most number of likes? So, would you upload something that's possibly funny like this? Maybe something like this? Or would you upload something that's terribly boring like this? Clearly, an algorithm which can take in the scenes and predict which is the funniest would be clearly a useful thing. However, there are some challenges to do this with real photographs. For example, in this scene, we need to detect the person, his pose, the beer cans, the toppled over chair, the barbecue, the lawn, and we need to infer that people usually don't tend to lie face down in their lawns. So our approach to solve these challenges makes use of abstract scenes. So these are cartoon-like scenes, and they're trivially densely annotated with an object's identity, its XY position, its scale or size, the expressions in case of humans and their poses. And it's really easy to create these scenes. You just drag and drop objects onto a blank canvas. And here are some example abstract scenes. We propose two tasks that we believe will help demonstrate an understanding of some aspects of visual humor. So the first task is, given a scene, predict how funny the scene is. And the second task is, given a funny scene, remove humor from the scene or reduce its funniness. Or, given a boring scene, make the scene more funny. That is, overall it's just altering the funniness of a scene. So to perform these two tasks, we collect two datasets. The first is the abstract visual humor dataset. This consists of both funny scenes and boring scenes that are created by Amazon Mechanical Turk workers. And the second dataset is the funny object replaced dataset, where given a funny scene, we ask Turkers to identify the objects that contribute to humor and replace these with other objects so that the resulting scene is not funny anymore. Let's take a brief look at some quantitative results from our work. So in the first task of predicting the funniness of a scene, our approach outperforms an average prediction baseline. And in the second task of removing humor from a scene, our individual modules of removing funny objects and adding in boring ones outperform strong prior baselines. Please visit our poster for more details. In qualitative results, in this funny scene where an eagle is carrying off a man's steak, which infuriates the elderly person, this funny scene, our model correctly identifies the objects that contribute to humor and replaces these objects with contextually meaningful objects like a boy playing ball and background objects like a butterfly. And in this boring scene, our model introduces in an elderly person who's doing a dangerous stunt and makes this funny. In human evaluation, we find that our model for humor suppression is successful 95% of the time. And we evaluate our model that introduces humor in a Turing test style, where we compare the originally funny scenes created by humans with the scenes that were made funny by our model. And we find that our model scenes were judged to be funnier than the human scenes 28% of the time, as compared to 50%, which would be human performance in this task. So please visit our poster. I'm looking forward to seeing each one of you. I think it's number 6, and thank you all for listening.